Welcome back to the Mechanics of Solids lecture series. In this series of videos, we're solving examples using Mohrs circle. In this video, we're continuing the example we started in the last video, working with this particular stress state. We already calculated Mohrs circle and interpreted some aspects of Mohrs circle. Now we're asked to consider a stress transformation from the current state at a rotation theta equals negative 15 degrees. We want to evaluate the transformed stresses and then evaluate them by inspection using Mohrs circle, and finally plot the stresses on a transformed view of the element. We use the stress transformation equations to calculate the transformed stress state. We want to use the angle theta equals negative 15 degrees. Sigma n equals sigma x plus sigma y over 2, negative 30 minus 15 over 2, plus sigma x minus sigma y, negative 30 minus a negative 15 over 2, times cosine of 2 theta, which is negative 30 degrees, plus tau xy, negative 35, times sine of 2 theta, or negative 30 degrees. This computes to negative 11.5. We'll compute sigma t from this equation equal to sigma x plus sigma y, negative 30 minus 15, minus sigma n minus negative 11.5. That computes to negative 33.5. We'll compute tau nt as the negative sigma x minus sigma y, negative 30 minus negative 15, be very careful with signs, divided by 2, sine of negative 30 degrees, plus tau xy minus 35 times cosine of negative 30 degrees. That computes to negative 34.1. Switching over, here's the stresses we just computed. This was for a transformation angle of negative 15 degrees. Here's Mohrs circle for this particular stress state with sigma x, negative tau xy here, sigma y, tau xy here. So by inspection, this transformed stress state on the circle is going to be a rotation of 2 theta, or negative 30 degrees in the clockwise direction from xy. So I'm going to sketch it right about there. 2 theta equals negative 30 degrees. That's where I eyeball my transformed stresses to be. This point right here would be sigma n, negative tau nt. Let's check it out. Negative 11.5, that's about right for sigma n. The opposite of negative 34.1, or up 34.1, is about right for tau nt. The other point would be 180 degrees, so somewhere down here. That would be sigma t, tau nt. Let's check it out. Sigma t, negative 33.5, that's about right. Tau nt, negative 34.1, that's about right. So everything checks. Last step, draw the stresses on a transformed element. Here's x, y. We want to go 15 degrees in the negative or clockwise direction. So here's the n, here's the t state. So I'll have my transformed element. It's almost too sharp of an angle. Transformed element looks something like that in the n t direction. Okay. All stresses are negative. Sigma n, 11.5 pointing inward. Sigma t, 33.5 pointing inward. And tau nt, because it's negative, we want to draw it in the downward direction on the positive n face. Just all other areas, arrows accordingly. 34.1, 34.1. So that's our transformed stress state. Everything adds up, and that concludes this example.